What don't you have? Okay. Now, for those of us who like titles, we're going to do the periodic table. Now, typically, this is one of our lower scoring units. And I think it is because we do 2 units together. This is one of the few times that I combine 2 topics. We're going to do the periodic table and bonding. If I didn't combine the 2 units, we would probably be ready to test on Thursday. And I don't like to do a unit that's so short we're ready to test after 3 days. So I combine the 2 units together. Unfortunately, it's a lot once we do that. You guys are an honor class and you need to get used to testing larger volumes of material. So it should not be something that should be unmanageable for us. Now, by the end of class, you'll sort of have a taste of where we're going tomorrow and understand why people don't like the periodic table, because we're going to talk about trends. And after, particularly tomorrow's class, which will be short for y'all, so you're going to have some homework tomorrow night. It's probably going to involve you guys watching YouTube and catching up on the pieces you don't have. I'm sorry about that. Not my fault, and some of you are going to have to do the pre-ACT. Just life of the students here at Lexington Junior High School. Everybody has to do it. At least those of you who are juniors aren't going to have to take steps tomorrow. Now, those of you who are sitting in a junior class, is your teacher teaching for 3 hours tomorrow? I'm just asking, is your teacher teaching for 3 hours tomorrow? Okay, if they're not, you already know ahead of time that you're going to have to do some form of notes for me outside of class for homework. So if you want to get ahead, watch some of the YouTube video at the end to get some of what you're going to need. You don't have to go to home tomorrow night. Because we're only going to get about 55 minutes of class. So the last 35 minutes of class, you're going to have to get on your own outside of class. Periodic, okay? What are you pointing at?
Yeah, I got it.
Whatever. All right, so we're going to start with a little bit of the history of the periodic table, first of all. All right? And there's a Russian chemist by the name of Dmitry Mendeleev. And this is one of the few times that I will teach you any history in chemistry class. But I think this one's important. You're going to take a chemistry class, and we're going to spend all this time talking about the history on the periodic table and spend all this time with trends. We ought to know a little bit about who designed it and how. Now, Dmitry Mendeleev designed the first periodic table. Now, just to illustrate a little bit of what he did, all right, he wrote all the information, and I'm just going to write info, he knew. All right, he wrote all the information he knew about each element on an index card. Now, first of all, I don't know in the 1800s if they were called index cards, but for the purposes of this discussion, he put them on cards. I'm going to call them index cards because it's something you can relate to. But what? I do not know if they saved those or not. If they did, I'm certain they have been saved and probably put in a museum in Russia at this point, but I really have no idea. Never looked it up. Now, but I want you to envision small cards of information that he's written down on, okay? The name of the element, the mass of the element, the density of the element, the boiling point of the element, the things they knew about the elements at that time on little cards, okay? Now, he arranged the cards looking for patterns. Okay, so So imagine that he has spread out all these white cards on a table. And he's trying to figure out if any of these cards have something in common and trying to find some kind of way that he can arrange this information into a useful table. Okay? And he found two patterns that he thought were useful. Okay? The first one he found is most increase in atomic mass. Now, the key there is most, not all. Some of the masses went down. We're going to talk about that in a minute. And number two, elements had similar properties. Now, because you have been in a chemistry class and in other science classes over the last few years, what do you know he did with the elements that had similar properties? Where did he put those? In a what? In a group. Okay? So the ones that were in a group or had similar properties, he put those in a group. Now, catch up with me, and we got to talk about these masses because there's a problem with what he was doing. Everybody there? Okay? All right. All right. So, most masses increase, but some went down. He could not explain why some decrease. Okay? He could not explain why some of the masses decrease. Had no idea why some decrease. So, here was his dilemma. He had selenium and bromine and tellurium and iodine. And tellurium had a mass of 127.6 and iodine had a mass of 126.9. So his dilemma became, does he switch so the mass does he switch them so the mass increases, or does he leave based on similar properties? Okay, that's his dilemma. So he's created this periodic table, very first one ever to be created. He's tried to arrange these elements. He's like, huh, The masses go up. But in some spots, they went down. I don't understand. Why do they only go down in a couple places? They should go up, like in all the other places. So, bromines, like I had done. Fluorine's like selenium. Should I leave them so they match with their properties? Or should I flip them so that the masses match up like they're supposed to like the other colors? What do you think he decided to do? He left them based on similar properties. All right? He said that the periodic table is based on similar properties, and this is the one he chose to do. He left them based on similar properties. Okay? Now, he was never able to explain why mass decreased in some places. Okay? He never was able to explain that. If I'm not mistaken, he died before it was able to be explained. So, why on earth would we be talking about a dude who couldn't even explain what was wrong with his table he created? Okay, you did begin, but there were other guys who were also doing the same thing that he was at the same time. Something is special about it, okay? Everybody caught up? Or do I need to wait? She's still right. I got it. Still right. It's fine. Are you sure? I don't want you to be left behind. I don't mind waiting. Okay. So, why on earth are we talking about Mendeleev when there are other guys working on this same concept at the same time? All right? Mendeleev predicted the existence of elements not yet discovered, and he predicted their properties. You do realize there's a Jake thing, right? Jake thing. Right. What about it? Mendeleev predicted the existence of elements not yet discovered, and he predicted the properties correctly. Now remember, this is a dude who wrote down this information on what again? Index cards. Read them out on a table. Okay? And he's thinking to himself, I should have other elements based on these numbers. There should be elements that nobody knows about yet. So there's got to be some missing elements. So in his periodic table, he left blank spots. He said these elements will be discovered at some point. Not only will these elements be discovered, but these elements will have these properties. This will be their mass. This will be their density. This will be their boiling point. This will be their formula. And not only that, he was right. Because he did those things, that's why we talk about Mendeleev and not the other guys who were doing the same thing he was doing at the same time, because they didn't do all those things. They just tried to create a periodic table. So, even though Mendeleev can't explain these masses, he did all this stuff. Okay? Now, have I got it? Because I'm going to show you his first periodic table real quick. You know, he's old. Cold and rough. Now, first of all, it's in Russian, and I don't speak Russian, people, so don't ask me what it says. Yep. I just hope you don't speak Russian. Okay? Now, these are the elements. These are the groups. Okay? Now, if you look, you see the question mark? That's a predicted element. These are predicted elements there with the question marks he said will be discovered. Okay? The question marks beside the numbers are going to be things that he's predicting that he's not sure of. Anything that has a question mark, he's predicting. All right? Like here, he does not know why tellurium is there as opposed to that. He doesn't understand why that mass is there and that mass is there. He doesn't know why it's out of order there. The what? I'm guessing those are decimals, if I'm not mistaken. I'm thinking in commas, those are decimals. All right, now, here are his predictions. Okay, he called it Eka aluminum because, you know, again, they didn't have a name for that because, you know, it was a made-up element at that point in time. All right? So, he predicted the mass would be 68. It was 69.7. Density was going to be 5.5 and or 5.9. It's 5.9. He said low for melting point, 29.8 is pretty low. There's the formula. There's the density. Here's another prediction, ecoboron for scandium. And you can tell he's pretty much right on the money. Here's another one for ecosilicon, turned out to be germanium. And he's pretty much on the money for those two. Okay? And because those are his predictions for 3 different elements, that's why he's given credit for designing the first periodic table and not some other time. Does that make sense? Okay. Now, again, and that was done with what? Index cards. Okay? Not something I would ever be able to do. Maybe y'all could, but I certainly could. All right. So, with the modern periodic table, what are the 3 new sections that have been added? Oh, it's getting hard. What are the new sections for modern periodic table? Let's big head up. What? Lanthanide. Okay, actinide. Yep. Oh. All right. Some basic information for you. The lanthanides are often referred to as the rare earth elements. Not real sure why, because they're not really all that rare. But they're often called the rare earth elements. The actinides are special because they're all radioactive. And the noble gases used to be called the inert gases. That name has changed since I started teaching. All right? And that's because, I believe, let me change that. It reacts, Kr and Xe react with fluorine. Okay? I'm pretty sure that the noble gases, the only 2 elements that react now are still krypton and xenon, and they react with fluorine. Okay? The noble gases, again, have 8 electrons. They are perfectly happy. So the only element they've gotten those gases to react with are fluorine. The fluorine has 7, so it's going to be pretty reactive. This is something we're going to talk about today. It's highly reactive. So they need something that's highly reactive to react with noble gases. The krypton and xenon that have gotten the reaction with the noble gases. So, given they have We had to rename the inert gases, so they named them the noble gases. So that name changed since I've been teaching. Okay? So they're always updating the periodic table as needed. All right? But now we're going to start with some trends today, and we're going to do two. We're going to do reactivity, and we're going to do form point, delta point, density, and part. We're going to do 4 more tomorrow. Okay? All right. You still write faster than double to the first period. Like that. All right, there. All right, we're going to start with reactivity first. So reactivity is something we did in the last unit. So we're just going to build on it and add another piece to it this unit. Okay? So if we go back to where we were, first of all, we're going to break reactivity into metals and nonmetals. And then we're going to talk about what happens in groups, up and down this time also, which will be the new piece we add. But before we do that, all right, let's refresh our memory. And then I'm going to ask you something and see if you would be okay with it if I asked you this on the test. Well, you never know. You might be. Oh, smart. I don't care what you are. Your name. Now, what do you suppose reactivity is based on? Hmm? What kind of electron? Okay, what's that other word we need to use for outer shell electron? There we go. Outer shell electrons and valence electrons mean the same thing. Now, I told y'all this last week. I usually say this in most classes. For some odd reason, you can hear me say it. When I teach the periodic table, I call them outer shell electrons. When I teach bonding, I call them valence electrons. I have no idea why. I've done it for 20 years. It's probably not going to change before I retire. But I just do it that way for some odd reason. Yes, I do. My official retirement date will be the end of 2021. Possibly the end of 2020. So, I have to work 4 years at my highest salary to not affect my retirement pay. So, 2021, it is entirely possible, yes. That's possible. I have a full year of 6 days, so it is entirely possible. Right? No, but I'm in the South of Texas, so I would consider my pay a lot of money. All right, so if we have reactivity based on outer shell electrons, all right, how many electrons are in the outer shell of group 1? Group 2? Group 13? 14? 15? 16? 17? And 18. Good. What will group 1 do in order to get to an octet? In group 2? And group 13? I think 14, I got to start catch up. And group 14? And group 15? Group 16? 17? And 18. Good. Now, metals do what with electrons to become an oxide? What metals do? Which metals do to become an oxide? Okay, like, I hear the piano next door better than I hear y'all. Okay, where are metals on the periodic table? Would be the first thing I'd ask y'all. Okay, over here on the left, right? So metals are over here. What's happening to their electrons over here? That's right. So metals lose electrons to become an octet, right? So if I draw in my staircase here, okay, and I change this to non-metals. Non-metals do what with electrons to become an octet? Okay, non-metals are over here, right? So non-metals, okay. Now, first period this morning, everybody was like, what happens if you got metals and non-metals and you're like in group 14? First of all, I'm not trying to be nitpicky if we have this on the test. These are two things that cause huge issues when a lot of people get these questions wrong. These are generic statements. Metal, being on the left side of the periodic table, do what with their electrons to become an oxide? Metal blue. Non-metals, being on the right side of the periodic table, do what? They get it. Okay? I'm not asking you specifically about one element in group 14. Non-metals gain metals lose. Okay? Does that make sense? All right. Now, thinking about what we know on here, right now, we're going to switch to just talking about metals for a minute. Then we're going to switch to talking about non-metals. Everybody there? Okay. So, if we talk metals, which group do we say was most reactive? Okay. G1 says group 1. All right. Y'all said group 1 was most reactive. All right. Who do we say was then the next most reactive when we were doing this? All right. You're a non-metal. So hold that thought when we get to the non-metal. Okay. Think only metal. So where are metals at? We go back to this picture. Metals are over here, right? We got these two groups. We got some D blocks. We got some down here, and we're going to just refer to these generically as the P block. Okay? So, what's wrong with you? All right, so who's the next most after group 1? What? 2. Okay, group 2 is the next most reactive. So now we're left the P block and the D block. Okay? So when I talk about the D block, where am I at for the D block? Right in the middle, okay? All right, so here is my D block, okay? This over here That's my P block. Okay, that's what I'm talking about. My metals that are under the staircase. So if I walk over here for a second, you see these blues that are right here in the P block? These are the few metals I'm talking about that are in the P block, like aluminum, gallium, indium, thallium, lead, tin. These few metals right here. That's the P block metals I'm talking about. All the rest of this over here, these are the D block metals right here. Okay? Which one of those do you think would be more reactive? The P's or the D's? P. Okay? Oh, sorry. I can't tell there's three P and D outside. Okay, P and then the D. So we're going to do these as greater than and less than sign. So group 1 is greater than, group 2 is greater than P, is greater than D. So D would be the most stable, or you could say least reactive. Okay? Now, that would mean group 1 is the most reactive. Okay? Now, the next piece we're going to add in is what happens if we go down the group. As we go down the group, they get more reactive. Right? As we go down, they get more reactive. So, if we look at group 1, what is the most reactive metal in group 1? Nickel. Okay? With neodymium. Okay. I'm going to ask you a question in a minute. Everybody good? So, if I say which metal is most reactive, and I give you choices of Mg, Ca, Cu, and F. How would we find our answer? This is very typical of what you will see on the next test. I know my head stuff on things on the sideline. How would we do it? What would we need to know? It would. Yeah. Now we have to do this usual crap. Come out. Now, how usual? Well, usually we keep some kind of lesson on internet teachers or like don't put stuff out on the internet. It's always there. For example, 10th graders this year are supposed to have this online relationship. 11th grade is supposed to solve ground stuff. 12th grade on cyberbullying. 9th grade is on Friday State Public tomorrow. Takes about a half hour to do it. Okay, so how do we do this? I'm just glad here I don't have to do this here because this is like a dream. Okay, first you gotta know if they're all metals. Alright, that's the first thing we can do. Let's put some up. Alright? So, what's the first thing we know? Are they all metal? No. Who's not a metal? Fluorine. That's the first thing I know. Is that's not a metal. So that's out of the run. Okay, what else do I need to know? Okay, first thing I do is locate where they are. Okay, so where's Mg? Alright, where's Ca? And where's copper? Alright, so D block. Because we don't have anything labeled group 11 in our trends, right? We know group 1 is the most, then group 2, then P, then D. That's the trend you just learned, right? So do I have anybody in group 1? Well, dang, that stinks, because that would have been the highest. We'd have been home free. That would have been the answer. Okay? So, group 2 is the next highest, right? How many do I have in group 2? I got 2 of them. So, the rule for group 2 is, as I go down, what happens? They get higher. So I need to know who's on top, who's on the bottom. Mg's at the top, Ca's at the bottom. So who's the most reactive? Yeah. See how we did it? Question. Okay. So, what's the rule then for non-metal? What's the rule for non-metal? What? Non-metals are essentially, well, it is for the up-down part. Okay, what group did we learn was the most reactive for non-metals? Group who? Go back to our periodic table. Who did we learn was the most reactive out of this section? Group 17. Okay? So if we cruise back here, group 17 is the most reactive. Then who was the next most reactive? 16. And then who? Okay. Now we could say group 14 here if you wanted to. Alright, but in group 14 you're really beginning to hit metal, metalloid, and there's one non-metal. So a lot of times I don't put group 14 in there because there's really only one non-metal at group 14. So a lot of times I will leave it off. You can put it there if you want to. There's nothing wrong with having it. Okay? I just don't often include it because there's really only one non-metal at that point. Okay? But it's fine if you put it there. Now, for the purposes of reactivity though, this one gets more reactive as you go up. Okay? More reactive as we go up. So metals are more reactive as you go. Metals are more reactive as you go down. Non-metals are more reactive as you go up. Now, I didn't write this because we were still talking reactivity. But if you want to, make sure you write reactivity beside that so you know we're still talking reactivity. Okay? So this is still a reactivity tree. Yes, dear. Why? Who's in the hallway?
Oh, no, there's
No.
no.
No, you don't. You sit right there. All right. That's one of those birds. If she wants to see you, then you can go out there. If not, then you can wait. All right, out of those 4, pretend they say A, B, C, D on the test. Okay, so out of those 4, we are trying to figure out who is the least reactive. Instead of saying most reactive this time, I've changed the wording to least reactive. Oh, you're only putting non-metal up there. Since I didn't say non-metal. I didn't give you any metals in the question, but because I'm not trying to throw you off. Okay. You still need water? You need water now.
I understand.
They say once you put it together, it never goes away. Maybe you have the skills to make it go away. Alright, so if you have that statement right there, and that's your question on the test, and those are your 4 A, B, C, D, A. How do you figure it out? Okay, you can. So, which group are they in? So, what do you know about your answer choices? Chlorine is where? And sulfur is? And chlorine is? And oxygen is? So, who do you know is automatically the most reactive? Chlorine and? So, you know those are out because they're the most category, right? Okay. So, they're both in group 16. So, you got O and you got F. Now, what happens is you go up. That's right. You know, as you go up, they get more reactive. So who's going to be the least reactive? S is the right answer. Sulfur is the right answer. Questions about how we did that? No. Now, the challenge, as you can tell, is going to be remembering the what? Remembering the pattern and the trend. Okay, we're doing 2 today. There are 4 more tomorrow. Some people said in first period that they counted these as 3. They counted this as 2. Okay. 4 days today. The earliest will be end of next week. The very earliest. Honestly, it'll probably roll into the next week. The last trend for today is boiling point. That's not blood pressure, by the way. That's boiling point. Melting point. Density. And hardness. Now, if you remember Earth science, y'all talked about the hardness of rock, talked about the Mohs scale. Okay? In chemistry, elements are also hard or soft. Group 1 elements are very soft. We can squish those with our fingers. They're so soft. In the D block, those elements are very hard. That's where our hardest metals are at. And everything else is arranged in between them. Okay? Now, the nice thing about this trend is it is the exact opposite of the one that we're doing now. So, if we look at what we just did, we're going backwards. So, who was the most reactive group? Oh, by the way, this is for metals only. I should specify that. We can't do non-metals because the non-metals are solids, liquids, and gases. Could we describe how hard sulfur is versus bromine, which is a liquid, and chlorine, which is a gas? No, not really. Okay, we can't talk about how hard a gas is. So we can only do this for metals. All right. So when we talk about metals, what group did you say was the most reactive for the metal? What? Okay. And who is the least reactive? D block. All right. For this trend, we're just the opposite. So flip it. All right. So the D block is greater than the P block, is greater than group 2, is greater than group 1. The D block is the hardest, most dense, highest, melting point, and boiling point. So that means the group 1 element will be the softest. They will be the lowest density. They will be the lowest melting point and boiling point. Okay? Will be the lowest. Now, the only thing you have to be able to do with this is apply it. So, if I say, which metal is most dense. And I give you choices of zinc, aluminum, lithium, and magnesium. It should be a pretty easy question for you as long as you know the trend. Done? Stop. Got it? What is it? What? All right, I hear C and I hear A.
Hold up.
Okay. Hold up.
Hold up.
So we got A and C on the floor. How many think A? Okay, I got a few more hands for A. How many think C? Okay, one. I got a whole bunch of people who didn't say anything. All right, so for those of us who didn't say anything, okay, I hear B out there. All right, so what can you tell me about zinc? Where is zinc? All right, where's aluminum? B block. Where's lithium? Where's magnesium? All right, most dense would be where? D block. No, most dense. If it was least dense, you'd have the right answer. All right, question. It is. All right, let's practice. Okay. Take it out. Good news. All right, let's practice real quick. Then I'm going to play a homework down your star. Hold on. Not go there. We'll take the zero. Okay. Let's quick ready. All right, real quick. Find me the answers to those eight. Yes, you can. You're not getting an hour. You don't need an hour, Brandon. You need an hour, and I'm getting an hour. Yes, this is called practice. It's a very technical term in education.
Yeah, maybe a lot of people. I want to tell them they're married to it.
All done?
Oh, yeah. That's right.
Are we done? We go? All right, pull up answers here. Hmm. Other than starting the homework, so, you know what to do. Yeah. All right, which one would be most reactive? Why? All right, it's group one, and it's at the bottom. There's two in group one, and it's at the bottom. Which nonmetal is most reactive out of that group? A, very good. All right, the only one in group 17. Which element has the largest density out of those choices in number 3? All right, why? Then the D block. Very good. Number 4, which element has the lowest boiling point? B. Why? It's in group 1. All right, which element is the least reactive out of those choices? All right, I hear A, B, and C. Where is A at? All right, A is in the P block. All right. I don't know if I can write on this for this one, or if I got to use that stupid thing. I think I got to use this thing. This thing. All right, so that's I always have trouble with these. Go away. I need. Let's forget how to do this. I need better. No, I just can't write on it. Yeah, I can't figure out enough funny. All right, so that's the P block. That's in group 18. That's a group 1, and that's a group 1. So we can agree group 1 and group 1 is going to be very reactive, right? All right, so that's in the P block, and that's in group 18. Did I specify what kind of element it has to be in the question? No, so any kind of element. And I said least reactive, right? So what kind of elements are the absolute least reactive on the periodic table? Noble gases. That's why it's noble gas. The answer is C. All right. The metal with the highest melting point would be which one? A. Because it's what kind of element? D block. All right. Which element will form a -3 ion? B. -3 ion is the same thing as a what? Oxidation number. A lot of people sometimes look at that and they're like, what are you talking about, Miss Wallace? But it's an oxidation number. So nitrogen is the right answer. And who has 3 outer shell electrons? A. That one should be an easy one. Everybody good with that? All right. Let me hand out the homework so we can talk about how to do this. The first one is really easy, and then the second one is just sort of yeah, you don't forget each other, okay? Everybody check your homework sheet. Let me clean that up. Might make it easier. Man. All right, let's talk about the element scavenger hunt first. All right, this is the easiest of the two. All right, this one is pretty cheesy. I cut down on the cheese. The directions were really long and really cheesy. It's still pretty cheesy, but like I said, I trimmed the cheese. You and your friends have been magically transported inside an 18-room castle built by the famous chemist Dmitry Mendeleev. Each room is entirely made of one of the elements of the first three periods on the periodic table. No element is repeated. All right? First three periods. No element is repeated. Everybody remember what the first three periods are? How many questions are on this worksheet? How many elements are in the first three periods? No element is repeated. If you venture outside of the first three periods, you will get the wrong answer. Okay? There are only 18 elements in the first three periods. There are only 18 questions. No answer is repeated. It does not spell anything either. Yes, I am. Okay? Now, you do not know where each element will appear in its state, solid, liquids, and gas. It retains at room temperature. So if you learn, for example, that oxygen is a gas, it's still a gas in these fluids. If you learn that sulfur is a solid, it's still a solid in these fluids. Okay? So if we do number one together, just to illustrate how easy some of these are, I know some of them will be harder, some of them will be easier. You suddenly materialize in a room made of shiny metallic solids. The room has been constructed of a lightweight, corrosion-resistant metal composed with atoms containing 3 valence electrons. Valence electrons is what again? Outer shell. It has 13 protons. It's the most abundant metal in the Earth's crust. What element am I? Aluminum. The only element with 13 protons and 3 valence electrons is aluminum. Write Al on the line. Wow. Okay? Now, you can't use aluminum again. It's already been used once. Okay? And continue filling them in. Some of them will be harder. Some of them will be easier. Okay? Yes, I am grading for correct answer. Now, some of you will work with your classmates. All I ask is that you not hand your paper to someone and say, here are the answers. If Eileen is working with John collaboratively, that's one thing. Don't hand your paper to Emmanuel because he didn't do his work and say, here are the answers to Emmanuel. Okay? Because he's doing his own work, right? He's doing reform since he came back from wherever he was at. I can't remember the name of the school. What was the name of it again? There you go. There you go. That was the name of it. All right. So on this one, all right, number one is the tedious one, and then 2 through 6 or so, you got to answer questions. Now, number one, you got a graph. If you get past the graph, then you got to answer questions. Number one is worth 70 points of the homework assignment. So if you're not going to answer the question, for God's sake, do the graph so you at least got a 70. Now, so that your graph works for you and you don't spend all your time jacking up the graph and rate. Pay attention now to help you get started. Now, first of all, turn your paper sideways. Somebody asked me this morning, did I care where the holes were? No. But if you keep it like this, it is not going to fit. It needs to be sideways. Now, this is quadrant 1 and quadrant 1 only. You do not need to divide this correctly. Okay? This is your origin, 0. You need, according to your directions, the horizontal axis will be what? What's the fact? What's on the horizontal axis? Atomic number. So if you look at your info, atomic number needs to go from 0 to what? 54. There are not enough lines to go from 0 to 54 unless you're going to get them tape about half another sheet of graph paper. So if you will number by 2s from 0 to 54, it will fit. It will not go all the way across the paper. It's going to be less than the paper. But you need another sheet of graph paper to count by 1. So count by 2. 0, 2, 4, 6, 8, so forth and so on. You got me? Don't skip lines. Just the same as counting by 1. Oh, you're doing it right. Yeah. All right, you got the idea? Yeah. Stop and you can count a little bit. All right, now look at your other data. Let's just tell you to label these y-axis 5. Do not forget to label your axis. I will take one thought. Atomic radius. So if you look at your atomic radius number, what must we get to on there? And don't just label X and Y.
What did it say the label on the horizontal axis?
Oh, that's probably the number.
Yeah.
Okay, so what numbers are we trying to get on the radius? The biggest number we need. Look. That was the common number. Sounds great. The biggest number we need. 2.16. Alright, so let's just round off to 2.2. So what would be a good number to count by on our trusty y-axis here if we need to get to 2.16? Point what? 0.13. Alright, so 0, 0.1, 0.2, 0.3, 0.4. When we get to 0.9, what's the next number after 0.9? 1.0. Okay? 1.0 and then 1.1, 1.2, right? And you can stop when you get to 2.2. Now, this is not going to be a straight line graph. It's going to be all up, down, down. Okay? You do not have to label the elements when you're drawing the dots. You do have to connect the dots. It's a line, not a scatter plot. Yeah, 2.2 is the highest you got to go. Okay? Make sure you label the axes. Both of them. You only label one, I'll take off point one, you forget to label. Because without labeling the axes, all you drew is a really nice scatter plot with lines and dots. Doesn't tell me. Now, once you've drawn the graph, you need to answer the question. I will tell you, most of you are probably going to want internet resources to answer the questions on the atomic radius. And it's okay.